Okay, so today you're going to be taking notes on what makes a solution, and then also a little bit of math involved in terms of calculating the mass percent. A lot of this really should be reviewed. We're just adding a little more chemistry components to it. So here we go. So what is a solution? So going back to first semester, a solution is a homogeneous mixture of two or more substances in a single physical state. These substances are not bonded. So remember, homogeneous mixtures, these are things that look the same all throughout. You cannot make out the different components of that mixture. So a couple of properties of solutions. The particles are evenly distributed throughout the solution. That goes back to the definition of what homogeneous means. And then all parts of the solution look the same. Also going back to what the definition of homogeneous means. So solute versus solvent. You probably discussed this a little bit in biology last year, but these are two words that we're going to be using quite a bit within this unit. So solute is the substance that is being dissolved, and the solvent is what's present in the greater amount. So these are two words that a lot of people get mixed up very, very easily because they're very similar to each other. I always remember it by the solute is what you are dissolving. You are dissolving the solute. For us in chemistry, the solvent 99% of the time is going to end up being water. So different types of solutions. There's alloys, gases, and liquids. So liquids is where we're going to put most of our focus, but I want to introduce you to the other ones as well. So alloys, these are metals mixed with another metal, so think of brass and steel. Those would be alloys. You probably deal with them on a daily basis, but it's not going to be the primary focus of our unit for us. Liquids is where we're going to put the rest of our focus. Liquids are miscible, okay, meaning that they can be mixed in any amount, so think water and ethanol. If they are immiscible, if the two liquids are immiscible, they are not a solution. Okay, this would be a heterogeneous mixture. So think about oil and water. You cannot mix those together, so therefore that would not be a solution. And aqueous solutions, where we're going to spend most of our energy, this is where water is the solvent. So solubility is the amount of substance that dissolves in a given amount of solvent. Okay, so salt versus sand. Salt is going to dissolve in water. Okay, sand is not. So types of solutions. There are dilute solutions and there are concentrated solutions. So dilute, they contain a small amount of dissolved solute. Think of like really weak Kool-Aid or really weak lemonade. Those would be dilute. Concentrated contains large amounts of dissolved solute. So think really, really strong Kool-Aid or really, really strong lemonade. For those of you who remember the Kool-Aid man. Okay, so a couple of definitions we have to cover: saturated versus unsaturated and supersaturated. Saturated is when a solvent or the water holds all of the possible solute that it can hold at a given temperature and pressure. Unsaturated, this is your dilute solution. It can hold more solute. And supersaturated, okay, is when there's extra solute that is dissolved. It's a very concentrated solution. One of the things you need to note about a supersaturated solution is that this can only happen if you heat it. So think about those of you who make sweet tea from scratch. You heat up the tea on the stove top and add your sugar to dissolve it. Sometimes then when you cool it and put it back in the fridge, some of the sugar falls out of solution. When it was heated, it was a supersaturated solution. Okay, that was the only way we could get that extra sugar to dissolve. So a couple of factors that affect the rate of dissolution. You are going to have to know these, so make certain that you memorize them. So temperature is the first one. Okay, and as the temperature goes up, the rate in which things dissolve goes up. Okay, this makes sense. I mean, just think back on things that you're familiar with. You put things in the microwave to help things dissolve. You get them warmer and they dissolve faster. Particle size. Okay, think about different sugar cubes. Okay, so with particle size, if you have an actual sugar cube, it's going to take a lot longer for that sugar cube to dissolve than it would a loose teaspoonful of sugar. So as the particle size goes down, the rate of dissolution goes up. mixing. Okay, the more you mix, the more that rate goes up. These are all three things that you should be extremely familiar with in your own life. You've done them since you were a little kid. The last one, which is probably new, is the nature of the solvent or the solute, whether it's polar or nonpolar, how concentrated it is or not. And we'll talk more about that as we get throughout this unit. Okay, the last topic we have left to cover in these notes are mass percent. And what is mass percent? It is a way to describe a solution's composition and expresses mass of solute present in a given mass of solution. So your mass of solute in grams over the mass of solution in grams times 100. The mass of the solution is just your solute plus your solvent. We've done this concept so many times throughout the year, we're just calling it by a different name now. So our first example, a solution is prepared by dissolving 1 gram of sodium chloride in 48 grams of water. What is the mass percent of sodium chloride in the solution? Well, my mass of sodium chloride is 1 gram. I have 1 gram of sodium chloride and 48 grams of water, so I'm going to add those together to get the mass of my solution. And then I do 1 divided by that total of 49 times 100, and I get 2.04%. Second example, a little different. 135 gram sample of seawater is evaporated to dryness, leaving 4.73 grams of solid residue behind. That's the salt that's in the seawater. Calculate the mass percent of the solute. So here in the problem, they give me the entire mass of the solution. I don't have to find it. It's given to me. So it's just 4.73 over 135 times 100 to give you 3.5%. The hardest parts about these mass percent problems is figuring out whether or not the problem is giving you the mass of the solution or whether or not you're going to have to find the mass of the solution. Other than that, these are very simple. And that is it for our notes today.